Okay, so now we're going to talk about states. So we know a few things already. Acids, they're always aqueous, okay? Elements can be either a solid, a liquid, or gas, so you're going to want to see your periodic table for that information. Molecular compounds, they can either be solid, liquid, or gas. And ionic compounds, if they're not in a solution, they're always solid. But if they're in a solution, they can either be solid or aqueous. So we need to look up this information using our solubility chart. So what I want you guys to do is to try these. So pause the video now, try them, take a little guess, then come back to it, start it up again, and we'll have the answers here for you. Okay? So here we go with the answers. We've got aqueous, solid, aqueous, aqueous. Number 5 is also aqueous. 6 comes in as solid. We've got 7 is aqueous. 8 is aqueous. 9 is aqueous. 10 is solid. Okay? We're going to look at some chemical reactions. Two things you guys need to know are endothermic versus exothermic. Endothermic absorbs heat energy, so it is going to feel cold, versus exothermic that gives off heat energy, and in this case it feels warm or hot. So we've got some reaction types. We've got hydrocarbon combustion. In this case we're going to have a molecule that is made up of some C's and some H's. It's going to react with oxygen to produce carbon dioxide and water. Okay, so for example there we've got CH4. It's going to react with oxygen to produce carbon dioxide and water. Next we have a simple composition. In this case we've got two elements. They're going to come together to form a compound. So here we've got magnesium and oxygen are coming together there. Okay? Simple decomposition is where a compound breaks down into two elements. So here we've got water is going to be broken down into hydrogen and oxygen. Okay? A single replacement is where you have one element and a compound is going to turn into a second element in a compound. So for example here we have copper all by itself, okay? And then in our products we have our other metal there all by itself, okay? So this is where again you have an element and a compound is going to turn into another element and a compound. Where we've got a double replacement is where we have two compounds are going to form two different compounds. So we have this lovely example there. Okay? Now, when we look for balancing reactions, the law of conservation of matter states that matter cannot be created or destroyed. It can only change forms. Therefore, we must balance chemical equations to conserve matter. So if I've got CH4, I'm going to add that to oxygen here, get my carbon dioxide and water, this situation is not balanced, okay? So my reactants, I've got 4 hydrogen molecules, and in my products I've only gotten 2. So in order to balance it out, I need to insert 2 coefficients of the value of 2 in order to balance it. And when I look at this other combustion reaction, okay, I know what's going to come out of it, alright? And here I've got to add some different types of coefficients in order to balance this out. Now, with this sort of information, you need to work on your next assignment. So your assignment now is page 8 and the first half of page 9.